Good morning, LS&GS student. This is your math teacher, Miss you all. Hope you are all safe. Our lesson today is about relative position of two planes, if they are confounded, parallel, and or intersecting. In fact, first of all, I'm going to start by if n1 and n2 are respectively the normal vectors of two planes p1 and p2. If n1 dot n2 equal to 0, then the two planes are in fact perpendicular, which is a special case of intersecting two planes, but they are intersecting at right angles. Now, in fact, how I can prove that two planes are intersecting? If we take the normal vector of the first plane and the normal vector of the second plane, if they are not collinear, then the two planes are definitely intersecting. And if n1 cross n2 not equal to 0, u over x over x not equal to y over y, whatever, or n1 is not equal to alpha n2, then the two vectors are not collinear, so I can deduce that the two straight lines, in fact the two planes, are intersecting along a straight line whose director vector is n1 cross n2. Why is that? Because if this is the normal vector of the first plane and the normal vector of the second plane, if we take the vector product, it will be a straight line of this form, which is parallel to the line of intersection. So the intersection of two planes is a straight line of director vector n1 cross n2. If n1 cross n2 equal to 0, then the two planes are either parallel or confounded. How I can prove if they are parallel or confounded? Simply, I can take a point from the first plane and replace it in the equation of the second plane. If its coordinates satisfy the second plane, then this point belongs to the second plane, so the two planes are confounded. If not, then the two planes are parallel. We have another way to prove that if two planes are parallel, intersecting, or confounded. In fact, if we have the plane P of parametric equations ux plus vy plus wz plus r equal to 0, and the plane P prime of equation u prime x plus v prime y plus w prime z plus r prime equal to 0. If u over u prime equal v over v prime equal w over w prime equal r over r prime, then P and P prime are confounded. If u over u prime equal v over v prime equal w of w prime not equal to r over r prime, then P and P prime are parallel, like this case. And if either u over u prime not equal to v over v prime, u over u prime not equal to w prime, or v over v prime not equal to w over w prime, then the two planes are intersecting along a straight line whose director vector is n1 cross n2. Now, take this example. Consider the plane P. In fact, I have four planes. The plane P x plus 4y plus 2z plus 6 equals 0, Q 2x plus 8y plus 4z plus 7 equal to 0, and T 2x plus 8y plus 4z plus 12 equals 0, and S 3x minus 2y plus z minus 2 equal to 0. We notice that by taking the two planes P and Q, I have u over u prime equal half, v over v prime equal half, w of w prime equal half, not equal to r over r prime. So I can say in this case that the two planes are in fact parallel. But if we take the two planes P and T, I notice that u over u prime equal v over v prime equal w of w prime equal r over r prime, then the two planes are confounded P and T. And the two planes P and S, I notice that u over u prime not equal to v over v prime, then the two planes here are intersecting. Another example here I have the two planes x, y minus z equal 2 and x minus 2y plus z equal 4. They ask us to determine the line of intersection of these two planes. We notice that here u over u prime is not equal to v over v prime, then they are intersecting. How I can determine the line of intersection of these two planes? I have a problem here. If we take the system x plus y minus z equal 2, x minus 2y plus z equal 4, we have here two equations and three unknowns. What can I do? I can transform t to the z to the second side. Also, I can replace z by t. I suppose that z is any real parameter. So we obtain for z equal t, x plus y equal t plus 2, x minus 2y equal minus t plus 4. Then we determine the values of x and y in terms of t. We obtain x equal minus 5 over 3t minus 4 over 3 and y equal 2 over 3t minus 2 over 3. So we obtain three values, x equal, y equal, z equal, which are the parametric equations of the straight line D, such that, which is the intersection of the two planes P and Q, of course, where T is real parameter. Distance from a point to a plane. Here we can use the formula. If H is the orthogonal projection of M on the plane P, so the distance from M to H, where M its coordinates are x0, y0, z0, equal ux0 plus vy0 plus wz0 plus r absolute value over square root u square plus v square plus w square. This looks like the equation of the distance from a point to a straight line in grade 10. We use it in grade 10, but it was used in plane geometry, not in space geometry. This method we are going to use it for, it is effective and valid only for the distance between a point and a plane in the space. If we have the distance between two parallel planes like this one, I have this plane and this plane are parallel, I can take any point of the first plane and we determine the distance from this point to the second plane using this formula. Here they ask us to calculate the distance from the point C, as the point M in the previous example, to plane Q, y plus 2z plus 1 equal to 0. Here I can replace the coordinates of C in the equation of the plane with absolute value over square root of the length of the normal vectors, square root 0 square plus 1 square plus 2 square. We obtain radical 5 units. Now another example, also consider the plane P of equation x minus y plus 2z plus 1 equal to 0 and the point A minus 0 minus 1 and 1. The distance from A to the plane P equal absolute value, we replace the coordinates of A in the equation of the plane, 1 plus 2 plus 1 over radical 1 plus 1 plus 4. We obtain 2 radical 6 over 3 units. If the answer is 0, then we can deduce in this case that A belongs to the plane. Now, another example also, here, calculate the distance from the plane R to the plane Q. I notice here that the two planes are parallel since their normal vectors are equal, or in fact are collinear. So I can take any point of the plane, of the first plane as the plane R. I can say let z equal 0. We obtain y equal minus 1 and we have here also x equal to 0. I can say, and I can take two coordinates of values of the coordinates of x, z example, and we obtain y. Then I can determine the distance from A to the plane R. We notice that the distance, it will be radical 10 over 10. How I can determine the angle between two straight lines? Using the formula of scalar product, r dot r prime equal norm of r times norm of r prime times cosine of alpha. Then simply I can write cosine of alpha equal r dot r prime over norm of r times norm of r prime. Of course, alpha is the angle between D and D prime, the acute angle between D and D prime, or I can also use sine of alpha equal norm of r cross r prime over norm of r times norm of r prime using the property of vector product. Here you notice that here I have n and n prime, and we use this formula. Between two planes here, yani the angle between two planes, I take the normal vector in the first plane and the normal vector of the second plane. Also we can use the same formula but by using normal vectors. Example here, I have the first plane, the second plane, I take the normal vector of the first one, which is 1, 1, minus 1, the normal vector of the second one, 1, 2, and 1, and we take n1 cross n of r cross n prime of r. We obtain 3i minus 2j plus k, and the norm of this vector is radical 14. The norm of the first vector is radical 3. The second normal vector is radical 6. We replace this, we obtain sine of alpha. Another example here. Also, if we have two planes, I have N, P, and Q, we use this formula again, and we obtain, but here I'm not going to use cross, I'm going to use the scalar product. We obtain half and cosine of -1 equals 60. In fact, I'm interested in determining cosine of alpha. Angle of a line and a plane. Here I'm going to, we notice that the angle between the straight line and the plane is alpha, and here I'm going to use sine of alpha by taking the director vector of the straight line and the normal vector of the plane. So sine of alpha equal r dot n over norm of r times norm of n, and this is all for today. Thank you.